You know those personality quizzes you see online? Ever wonder how on earth did they come up with these questions? A lot of the time, it feels kind of random, right? But behind any good psychological test, there's a really rigorous science at play. So today, we're going to pull back the curtain and explore how scientists actually build the tools that measure the invisible but powerful parts of our minds. And that's the big question, isn't it? I mean, you can't put a tape measure to creativity. You can't weigh anxiety on a bathroom scale. So how do you possibly capture these abstract concepts? Well, it takes a very, very specialized kind of tool, one that's built with precision, a ton of theory, and a whole lot of data. And that tool is the psychometric scale. I love this analogy. Think of it like a voltmeter for the mind. It's a set of objective, standardized questions that are carefully, and I mean carefully designed to get a reliable reading on some unobservable trait, what scientists call a latent construct. It's all about turning those fuzzy, subjective feelings into objective, measurable data. So to really get how these are made, we're going to walk through the whole thing step by step. We're going to frame it like an artist sculpting a masterpiece. First, we'll figure out what we're measuring. Then we find our raw material. We'll do some initial chiseling, polish it up with data, and finally unveil the final product. Let's get into it. Okay, first things first. Before you even think about writing a single question, the most important work has to happen. You have to define exactly what it is you're trying to sculpt. Here's the thing most people don't realize. You don't just start writing questions off the top of your head. You start in the library, metaphorically, of course. Researchers dive deep into all the existing scientific literature to create a super precise, crystal clear definition of the construct. So if you're measuring, say, self-efficacy, your definition has to be grounded in established psychological models. This theoretical foundation is everything. It's what gives the scale any real meaning. All right, now that we have our blueprint, that clear construct definition, it's time to get our raw material. A sculptor starts with a massive block of marble. A psychometrician? They start with a huge list of potential questions. We call this the item pool. And when I say huge, I am not kidding. We're not talking about 10 or 20 questions here. We're talking about generating an initial pool of 80, 100, sometimes way more items. The whole point is to be totally exhaustive, to capture every single possible angle of the construct, knowing full well that most of this raw material is going to get chipped away and thrown out. So, where do all these questions even come from? Well, there are two main approaches. You've got the top-down or deductive method, where you create items straight from the theory and research. And then you have the bottom-up or inductive method, where you actually go talk to people. You use their own words from interviews and focus groups. You want to know the gold standard? According to the research, it's combining both. Okay, we've got our giant block of potential questions. Now it's time to bring in the master sculptors to make the first big cuts. This is the expert review phase, and it is absolutely critical for quality control. So you assemble a panel of subject matter experts, and they go through every single item like judges. They're asking, is this question actually relevant to what we're trying to measure? Is it perfectly clear with zero ambiguity? Is it short and to the point? And, this one's huge, could the wording be interpreted differently by people from different backgrounds? Any question that gets a no is in trouble. And this is the exact kind of feedback you get. An expert might spot what's called a double-barreled item. It's a classic mistake where one question is secretly asking two things, like, I feel energized and focused at work. Well, what if you feel energized but not focused? The question is useless because the answer doesn't mean anything, so it has to go. Now, what's really wild is just how ruthless this process is. We're not talking about a little light trimming. This is a massive culling. Honestly, this step is what separates a real scientific tool from a BuzzFeed quiz. It's this relentless pursuit of quality that leads to more than half the original questions being thrown in the trash. It's basically survival of the fittest for questions. And here you have it. This is the result of all that chiseling. Our block of 100+ questions has been shaped down to a much more refined, focused set of maybe 15 to 25 items. These are the best of the best, the strongest, clearest, most relevant questions that survived round one. The rough form of our sculpture is starting to emerge. But to get those fine details, that perfectly smooth finish, we need to switch from human judgment to the precision tools of statistics. This is where we polish the scale with data. The main tool for this job is something called factor analysis. Now, it sounds super complicated, but think of it this way. It's a statistical method that sifts through everyone's answers to find hidden patterns. It might notice that questions about, say, pay and benefits all kind of move together, while questions about teamwork and your boss move together in a different group. It finds these families of questions, these factors, to show you what underlying dimensions you're really measuring. And this whole process is kind of like a two-step dance. First step is exploratory factor analysis, or EFA. This is all about discovery. You just let the data talk and see what natural clusters pop up. Once you think you have a map of the structure, you move to step 2, confirmatory factor analysis, or CFA. Here, you get a totally new batch of data and you test a very specific theory. Does that structure you think you found actually hold up? It's this crucial cycle of discovery, then confirmation. And you have to remember, this isn't a one-shot deal. Not even close. It's a cycle. Researchers give the test, analyze the data, tweak the items, maybe drop a question that doesn't really fit with its family, and then they do it all over again. This loop continues until the scale is rock solid, stable, and has acceptable psychometric properties. At long last, our sculpture is complete. It's been carved and chiseled and polished to perfection. But for it to be useful, we have to put it in a gallery. We have to give it context. And this is the final, crucial step, standardization. Think about it for a second. If I told you that you scored a 42 on my brand new test for creativity, what would that even mean? Nothing. Absolutely nothing. A raw score is meaningless by itself. The process of norming is what breathes meaning into it. You give the final test to a large representative group of people to establish what's normal, to get a baseline for comparison. And this table shows you exactly how that magic happens. Your raw score 42 gets statistically transformed into a standardized score, like a T-score, where we know the average is always 50. So a 65 instantly tells you you're above average. Or even better, it can be converted to a percentile rank. A score in the 93rd percentile, that means you scored higher than 93% of the people in that original sample group. Now that is a meaningful number. So let's just recap the entire incredible journey. As you can see, it is a systematic, multi-phase marathon. You define the construct, generate a ton of items, assess their validity with experts, you pilot test, you field test, you analyze the data, you validate the scale, and finally you establish the norms. It is a true marathon of scientific rigor. Which leaves us with a final thought for you. The next time you stumble across a quiz or a test online, just ask yourself this. Was it painstakingly sculpted through this whole scientific process to make sure it's valid and reliable? Or was it just typed up? Now you know what it takes to tell the difference.